Welcome to video number 2 on ellipses. So in the last video, we learned about the parent ellipse, and we learned there were 2 types of ellipses, a horizontal ellipse or a vertical ellipse. So today I want to talk about all of the specifics of a horizontal ellipse and make sure you're taking excellent notes so that you can refer to this in your next set of assignments. So the equation for the parent ellipse that's horizontal is x squared over a squared plus y squared over b squared equals 1. And to be a horizontal ellipse, a has to be greater than b, okay? So we're gonna go through all of the vocabulary that you'll need: major axis, major radius, minor radius, vertices, covertices, foci. And we're going to talk about standard form, okay? So what we're going to do is draw a picture of what this would look like, okay? So here's my coordinate plane, the x-axis and the y-axis. And I'm going to draw a general looking horizontal ellipse. So something roughly along these lines, okay? It doesn't have to look perfect. Now, the first thing I want to talk about is the major axis. This is asking which axis is the larger or longer axis. And in this case, in a horizontal ellipse, the x-axis is the major axis, okay? That means the minor axis is going to be the y-axis because this is the one that's shorter in length. Okay, now, the major radius. So think about this. Major radius is going to lie on the major axis, okay? So the radius, it's kind of like the concept of a circle, is going to go from the center out to the edge. And this distance here is the major radius. So the major radius, or the length of the major radius, would be A, okay? Now that means this point here, very importantly, would be called A, 0. And this point, A, 0, is what we like to call a vertex, okay? Now, what that means is this distance here is also a radius, specifically the major radius, but this point here would be -A, 0, making this point another vertex, okay? So hopefully that makes sense. So when it's talking about vertices, right, they are talking about, again, these points that lie on the major axis. So -A0 and A, 0, these are both vertices, okay? And this distance here is A, this distance here is A, okay? And we'll do examples later with actual numbers. Now, you can probably guess what the minor radius would be. The minor radius would lie on the minor axis, and those would be sort of connected. The minor radius would be the letter B. So this distance here would be the minor radius, okay? Which would mean this point here would be the point 0B. And I can't call this a vertex. I have to call this something a little less important than a vertex. After all, this point is on the minor axis. I'm going to call this point a CoVertex. So the way that I like to think about this is like pilots and co-pilots, right? The pilot is the main person, probably the most important person on the plane. The co-pilot is there to assist and be a backup. So the vertex is the most important point. It's on the major axis. The covertex is on the minor axis. That would mean that this distance here is B, and this point here would be 0, -B, also a covertex. So when it talks about covertices, that's what they're talking about. Okay, now this is an interesting thing. So what is a foci? Foci comes from the word focal point, okay? And what is going to happen, and this is going to be something pretty cool about the ellipse, somewhere on the major axis, so the foci, these are going to be on the major axis, they're going to be points that are equidistant from the center. And foci are going to use the letter C. So this point C0, this point negative C0, these are foci or focal points. And we're going to see in some future videos that focal points have really, really cool properties. If you guys have ever heard of those whispering galleries or, ever done those experiments in science museums where one person stands on one side of the room and they can hear the other person talk, these are all due to focal points on an ellipse, which we'll learn about in future videos. So foci are these points here, and these are always going to be on the major axis. Okay, now, just as an FYI, please write this down. To calculate the letter C, and we'll derive this later, you're going to do plus or minus the square root of a squared minus b squared. And that's a formula that we will derive later, but just make a big note of that, okay? And then finally, because we have the parent ellipse, we need to talk about standard form. And standard form is going to use the similar logic as a circle. The way that you have standard form for horizontal ellipse is you have the quantity x minus h squared all over a squared, okay, plus y minus k quantity squared all over b squared equals 1. The center of the ellipse, instead of being at 0, 0 like our parent, is going to be, again, at the point hk. Again, A is still greater than B if we're a horizontal ellipse, and we're going to see that the distance A is going to be from the center point. So in future videos, this will make more sense. So just make sure that you go over this video again if you need to, take very good notes, and I will see you in the next video.